Good morning, good afternoon, and good evening. My name is Andy Digelman. I am the Chief Product Officer at TCG Digital. It's my pleasure to welcome all of you to our exclusive tcgmcube 5.1 launch webcast. We have a packed program today. We will have presenters talking about artificial intelligence for the enterprise and how our new platform accelerates time to value. Promise, this event is not artificially generated. The presenters are real human beings, and the software platform and solutions we show are generally available today. We will start off with a view from our CEO, Devdas Sen, followed by some of our customers in the process manufacturing and life sciences industries, explaining the impact tcgmcube has on their daily operations. We then move on to the most impactful and innovative features in our new release, illustrated by GenAI and multimodal workflow demonstrations by our resident data science practitioners, Panchali Rao-Chowdhury and Ashutosh Rayan. Please post your questions in the chat so we can close out with a lively and exciting QA session. On to Devdas' quick keynote now.
Hello and welcome. Today we launch tcgmcube 5.1. I look forward to this day every year when I can talk about all the fantastic stuff that we have done in the area of AI in our AI platform. And it's a pleasure to serve you as our clients, as our esteemed clients, and to be able to add value to your great organizations. Talking of value, one of the things that we have been very heavily focused on is to be able to improve EBIT, to be able to improve profitability in operations, whether it's in the area of airlines or whether it's in the area of manufacturing and pharma or large manufacturing units and refineries and petrochemicals or consumer products and goods. That has been a core area in which we have been focused on. And what we do is we take the business perspective, and business value comes first always with us, and then use modern technologies to be able to get to value faster. And some of you may already know that our mantra is velocity to value. And to be able to do that, what we do is we integrate the best of what we do in our research center along with what others are doing in their research center and be able to bring that together and then give it to you in a way so that you can get to value fasted, so that time to value is least to you. For example, uh, generative AI has significantly matured over the last few years, last couple of years, and we are very, very abreast, and we keep ourselves very close to all the fantastic stuff that's happening from Meta with Llama 3 and with Google and Gemini 2 and with Anthropic and so many others. And then also with AWS and Oracle, and these two clouds specifically has done some outstanding work along with Azure that has been there for a while. And be able to bring this to you in a way along with traditional AI, traditional data management, and packaged in a way so that impact is there fastest for you. And you'll see a lot of that. So one of the things that we do is take the best of what you have, of all the fantastic investments that you've made in the area of AI data. Take what we've done in our labs, take what is there in the outside world, in the open world, and bring that together for you to solve your business problems quickly. Of course, there's a lot of private LLM in that, a lot of agentic AI in that, and I wouldn't take the steam of the speakers who are to follow, but but there is a fantastic piece that is there for you to see. And how do we combine core data management with the world of generative AI, and then we add knowledge graph to it, and then you'll see that very soon. I'm also very excited to see the showstopper of our show today, which is what we call AI 2.0, or the modern day AI data management, data pipeline that we have been able to bring to you. Again, which brings together a very, very, very large library of AI functions, and you would be able to solve your problems using that very, very quickly. So without much ado, I'm going to hand it over to the other speakers, our clients, of course, our product team, and you're going to go for a fantastic ride in the next 1 hour as we launch tcgmcube 5.1.
All right, so that's so much from our CEO, Debda Sen. Let's now move on to what our customers have to say.
So LLF, or look, listen and feel automation, the people in other terms call it operator-driven reliability, is basically to ensure that we have a safe and a reliable operations, and what we are seeing in the plant is communicated back to the control panel in a more real-time manner, and that's more important for us. See, we in HPL wanted to do something very specific to our requirement, and also bring an innovation in the technology which we would like to use. So we had a very clear vision when we saw the market with the ready-to-use solutions or the cost solutions. They were not meeting the full requirement which we were looking for. Like we wanted a solution which is basically can be leveraged through a mobile and a web interface. It should also be able to take in the geotags data, so that we can have a geofencing to ensure that whenever an operator is taking the field round, he is at the right place. We also wanted an application which will interface with the QR tags, so that when he's near to the asset and only he's supposed to take the readings. And we are also able to make operators pinpoint the altitude part of it, because in any refinery complex you will have a lot of areas where you have to move up and down, So we were having a very clear idea that application should also be able to communicate with NFR tags, the near field communication tags. Now all these facilities with a bit of an AI-based analytics, which will be a near real-time analytics, was not there in the other products in the market. So here we thought, this is an best of the both worlds for both of these entities, TCG Digital and HPL, to collaborate together. And that's the reason why we choose MCube Analytics the platform, which had this inbuilt analytics, and this features which we were telling you were basically customized and built in to our needs. So today, if you say this partnership has got us into some sort of a unique product to be built for a petrochemical industry. Why I'm saying unique? It is not a a mundane inspection logbook only, or somebody going into a round and filling up your forms. It has got an intelligent framework built in. It has got a governing compliance built in, and it has also got some sort of a real-time analytics available for the operator and the supervisors to communicate between together. So that's the USP of this product which we are building.
Reduced time to value, increased efficiency of business processes, and accelerated innovation around AI in the enterprise. It's always great to hear from our customers. Let's have a look at the AI platform our customers were referring to. Driving tcgmcube forward, we are laser sharp focused on dealing with the humongous variety and velocity of today's structured, semi-structured, and unstructured data landscape. While many data ingestion challenges are solved for the most part, getting data out, making data and information useful across the enterprise is still a challenge we and our customers focus on. With the addition of semantic technologies like generative AI and knowledge graphs, we are making strides to make sure the data and documents in our lakehouses are findable, accessible, interoperable, and reproducible. However, the most significant innovation in tcgmcube 5.1 is our vastly extended and reimagined end-to-end AI and machine learning workbench, AI 2.0. It brings the complete path from inception of a project to getting familiar with the data, to feature engineering, to experimenting with different models, to train the models, to identifying the champion model, to deploying the model into production, and then to continuously monitor model and data drift to understand when corrective action needs to be taken. The model variety that can be handled inside a workflow is unlimited, from machine learning to AI deep learning approaches to computer vision and the latest generative AI models. Every significant step to get to the best model is supported by automation on one hand, and the ability to fine-tune it on the other hand. GPUs can be leveraged when desired. Even large language models can be incorporated locally to be able to keep enterprise information confidential. If data scientists prefer to write code by themselves, they can add a code node to the workflow without compromising the transparency and compliance required to move to production quickly. With hybrid Gen AI, we have addressed the main challenges when using large language models for information exploration: completeness, accuracy, and transparency of the summarized answer the end users get presented with. Through the combination of probabilistic large language models, retrieval augmented generation, and ontology-based knowledge graphs, we drastically reduce hallucinations, get complete answers, and reference directly the source documents that contributed to the answers. Trustworthy AI. Ever since we drastically reduced the development and deployment time for analytical applications by launching our low-code development framework called EasyExtend and our microservices architecture called Genie, customers have started to leverage AI applications not only in their offices, but close to where the action is. On the shop floor, for example, as we have heard from HPL. Thanks to our responsive design, adapting to different screen form factors happens now automatically. As data science teams and the number of end users leveraging analytical applications are growing in number, centralized credential management across the enterprise to protect the data assets has become a very strong desire for our customers. Through our secrets management service, tcgmcube can participate in centralized vaults like SSM from AWS via simple configuration. A big step forward to not only trustworthy, but safe AI applications. I think this should be enough of an overview. Let's now dive in and see tcgmcube 5.1 in action. And with that, over to you, Panchali.
Sandy. I will now illustrate the powerful combination of generative AI and knowledge graphs in the platform, showing you how it helps in efficient search and discovery of information. Let's assume for a moment that I am a R&D scientist in a pharma company, and I need information on different genes for my oncology research. So the first thing I can always do is I can go to ChatGPT. Today, everyone goes to ChatGPT and type out what I'm looking for. So on ChatGPT, I go, okay, what are the genes involved in hepatocellular carcinoma? Maybe that's my area of interest. So ChatGPT will definitely give me insights and response. So it identified 11 genes for me. But I know that my organization, my pharma company, has done extensive research in HCC or this particular cancer. And I have a lot of proprietary documents available within the organization, which can give me even more comprehensive insights. Now, how do I get that information? Now, that is where the power of private LLMs, which can work with proprietary data and ensures that the data does not go out, so my documents remain proprietary. So we trained, using tcgmcube, we could do a RAG-based private LLM model, which was trained on the proprietary data. And now, with that additional information, it was able to identify 31 genes, which is a huge difference from what ChatGPT could give me, because ChatGPT was only basing its knowledge on what's publicly available. Now, can we do better? Can we get even more information? That is where knowledge graphs come in. And when we add knowledge graphs to Gen AI, the results are amazing because the hybrid approach leverages the structured precision of knowledge graphs and marries that to the flexibility and breadth of RAG models. and creates a more contextually aware system, which makes it even easier for me to get contextual information out. And with this hybrid model, I was able to identify 44 genes on that same repository. So which gives me a lot more insights that I could have imagined. So now, with this, I wanted to give you a short demonstration of what the Gen AI knowledge graph solution looks like. So as you can see, it quickly gives me a response, and it also provides the references to the response. So I know exactly where the information was sourced from, so that it can give me, so I have more confidence on the response. I know the model is not hallucinating, and I get appropriate insights. I can ask follow-on questions to this. So maybe I want to understand what is the latest treatment for brain cancer. So again, I type out the question, and leveraging the knowledge graphs and the Gen AI, it's able to give me a very contextual response on the different treatments available for brain cancer. And again, the references really help me go deeper and into the information and understand the source of this information. It remembers the context, and on the right-hand side, you can see you have the archive of previous queries. So I can always go back and look at past results that I received on various queries that I've asked. Let's ask one more question on this disease area. So what are the potential therapeutic targets of brain cancer? And let's say brain cancer is an area that I'm researching on, and it's very important for me to understand the targets for brain cancer. And yes, it's able to give me quite a detailed response, which is super helpful for my research. And now, with this response, we can try asking more difficult questions, in the sense of, questions on what is like really new age. So one of the things that's coming up nowadays in a big way is the use of digital twins. And as a researcher, I want to understand how digital twins can help with brain cancer. So again, I go in and type out digital twin for brain cancer, hoping that the solution is going to give me some response. And yes, it does. Even the solution thinks it's a very fascinating topic and gives a detailed response, along with, okay, here it gives me references to certain journals and papers. So now maybe I want a summary of one of these references. I may not have time to read through everything. So I want the solution now to go through maybe the first reference that's given, Nature Medicine, and kind of summarize the information that's available for me. So I just type out summarize the paper and put in the name of the paper. And it quickly summarizes the information for me, so that I don't have to go in and read everything. So maybe this paper is interesting for me, and I want to know what other similar publications are there. So I can go in and type out that, show me publications that are similar to this one. So that's what I type out, hoping that I get, references to some other journals that I could possibly read up on in this area. And I wait for the response. And yes, absolutely, it gives me quite a few references. So now I am all set to continue my research on brain cancer, and I get all the information from here. So that was a short demonstration. Handing it over to you, Andy.
Thank you, Panchali. Quite amazing how trustworthy suddenly generative AI can get. And now I think we should move on to Ashutosh, who will show us the way to deployment of a production AI model end to end. Over to you, Ashutosh.
Thank you, Andy. Hello, everyone. Let's train a customer churn prediction model now. Let's head back to classical machine learning, which can never get old. To demonstrate how quickly you can go from concept to production with our next generation AI platform. And this demo will cover not only the data science life cycle, but also the MLOps parts. After logging into tcgmcube, we will head directly to our artificial intelligence module. Here you will see two options. Either we can create a new project or we can open the existing project. In this demo, we are going to create a new project and workflow from scratch. The project name is the only mandatory field here. So whether you are a citizen data scientist or a seasoned decision scientist, we offer a set of parameters that can help you build your project, like explainability rules, latency, throughput, which can set guardrails on which model to select. And on the left hand side panel, we have multiple options to read data from a structured, unstructured source, scheduling the final workflow, and MLOps. So let's deep dive and create a workflow. We will name it customer churn prediction model, and then I'm going to keep the description and GPU support disabled for now. And once I create this workflow, then we get a canvas where we can start the executor. Executor brings in a kernel, executor kernel in the backend, and now our workflow is ready to uh, ready for adding new nodes. So let's start by adding read data node. It's just a drag feature, and then we will select the hyperparameters from the left hand side panel. So here we just need to select the data source. So we have a pre-configured data source, and let's hit on run button. As soon as we do it, you have seen that without writing a single line of code, we are able to read this data, and we can see the preview on the screen, where we will see basic information like row count, size of the data, all the numerical as well as categorical variables like income, and finally, you will also be able to see the summary report. And this summary report contains the descriptive statistics like 5-point summary, as well as basic things like missing value. This helps me get the idea, high level understanding of the data. Now, if I want to deep dive into data, let's add an auto EDA node. EDA stands for exploratory data analysis. Here, again, with a click of button, we can generate the complete EDA report, which will not only have the univariate analysis, but it will also have multivariate analysis. And by multivariate, I mean the correlations, interactions between variables. So now our report is ready. Let's look at it. We have overview, then we will see lots of alerts related to data. And this is kind of contextually generated already. So income is highly correlated with handset price, etc. So these are all alerts that we are getting, which can help us form our hypothesis. Then we look at individual variables like college, income, what is the distribution, what are the descriptive statistics. So for example, for overage, we will see all the quantile statistics and descriptive statistics available. Now let's move on to the multivariate analysis. So how two or more than two variables are interacting with each other. Pearson correlation coefficients, where you will see that income is again highly correlated with headset price, which is intuitive, right? So once we look at this complete report, we get a sufficient amount of hypothesis to be able to model our and choose the algorithm and model our problem statement. Now we will move, after EDA, we will move on to data pre-processing steps. So we will start with missing value imputation, very important because it can help you massively boost your accuracy. And we have seen that there were some missing value also available. We can also create some simple charts from the top library. You see area chart, bar chart, etc. And it's again just drag and drop functionality with some click of configurations without writing any code. Now coming to data pre-processing again. So missing value imputation is there, which we are going to do. Then outlier analysis we will be doing afterwards. So in missing value imputation, we have to just select the columns that where the missing value is present. And after selecting it, I have to select the strategy, whether I want to impute with a fixed value or median or something else. Now let's take a leap in the interest of time. So I have already added outlier analysis, feature encoding, again very important for categorical variables, data split, and our data is ready for machine learning algorithm building. So training the model. Here I am going to select classification, since this is a binary classification supervised learning problem. We will start with decision tree classifier because it is the easiest one and easiest to visualize as well. If it is a single decision tree, we can select the target variable and all the input variables that we think is independent. And then we also have either general parameter or advanced parameter, which we can hyper parameter, which we can fine tune from the left hand side panel. Once our model is getting trained and now it's ready, we will predict and then evaluate. We will do the prediction on the blind test data and then evaluation using F1 score. So here you can see the F1 score that we are getting is 0.6, not bad for a model that we are trying to create in last 5 minutes, right? And now let's try with some more algorithms because decision tree is generally prone to overfitting. So we will try with the logistic regression and also with random forest quickly. And for logistic regression, you will see that our F1 score has slightly increased to 0.63. And then I'm going to do the same step with random forest, which is an ensemble model. Again, comes out of the box in our AI platform. And here, again, let's look at the F1 score. And now you will see the F1 score is 0.698. So in last 2-3 minutes, you just have seen that how our F1 score has jumped from 0.6 to 0.7, around 0.7, by just switching the algorithms. And it's very intuitive and easy to do in our next gen AI platform. Now our model is ready, let's say, and we are ready for our champion analysis. What are we going to do next? How are we going to do the productionize this model? So we have two options. First, let's also add the node to write the data back to our database. It can be any database of your choice, which can be connected from here, and you can write the data. After you have set up the complete workflow, we have two options. Either we can schedule this workflow so that it will run every day at a particular time, or every hour. You can also schedule it. The second option, so scheduling is very easy. Again, you don't have to write any cron jobs, any code, just select some features and you are good to go. Next option is the creation of API, where you want to use the model serving in the real time. But before we go there, I will also show you our MLOps library that we have just integrated, where you can have a complete track of all the models that you have trained. So in last 7 minutes, I have tried 3 different models, and all these models are saved here. I can go to this interface and compare these models metric by metric to be able to understand. So here I just used F1 score in the interest of time. For your use case, you may have to use precision, you may have to use recall, etc. After you compare the model, then you will select which model is the best. You already have got some indication on our front end application using evaluate node. And after you are ready, you can register the model in our model registry. So then this model version will be tracked. So every time you are going to update this model. And why we need this model versioning? Because we want to not only deploy the model and leave, we want to keep tracking the model for its accuracy, for its model drift, for its data drift, and all those things are inbuilt in this module. So let's register the model, providing our model name, and then we will again, after registering, we will head back to our we can download the pickle file from here in our local, so that we can again upload it and create the uh, Docker image in the backend. So again, in case of creation of Docker image and productionization, we don't have to write any code. It's just one touch production ready application. Here I'm going to give my API name, upload the pickle file from my local machine, and if I can put requirement.txt if I am using some custom libraries from Python, which is not natively available out of the box in our environment. Once we deploy it, we have to just click on run. Now our service is ready to be used. So we have two URLs here. One is to get the schema, and the second one is to predict. So for any system to use my API, they will need to know the API signature. And here in this is my local machine, Postman. Using Postman, I have called the get schema API, and I am able to get the schema. What all variables are required, like average, call overage, and other variables are required to uh, get my prediction. So now I have to call the other API, which is my predict API, and here I have to put some value in these fields, right? Average call duration, headset price, house, income. So I'm going to put some value. I have some intuition about what my customer data looks like. Those value I'm going to fill, and just I have to click on send button. What it is going to do, it is going to call the API that we have just deployed, and then we will get the final prediction. So now let's fill this up and click on send button. Okay, so here we are getting an error because I have selected get. This is a post API, so I have to correct it, and then we have our prediction that this particular customer has probability of leaving, right? So as promised, we demonstrated how quickly you can go from start to production with our generative AI module. Over to you, Andy.
All right, thank you, Ashutosh. I think you all agree with me that Ashutosh probably has just set a new world record to get a production AI model out from inception to actually execute it. Let's now look at two very innovative AI applications involving multimodal workflows. And for that, I hand back over to you, Ashutosh.
Yeah. Thank you, Andy. In this demo, we will see innovation in action as we explore the multimodal capability of our next generation AI platform, combining classical machine learning, computer vision, privately hosted large language models, and time series analysis to solve a critical challenge in the insurance industry. So our first use case involves building an ensemble model, which you can see on the screen, to predict car insurance premium from different set types of data. This model integrates machine learning for tabular data such as driving history, claims history, a CNN model for car condition image data, and a time series model for fixed overhead charges. So in the first part, we will go ahead and ingest our data from our database. So let's first start by building our classical machine learning model using FNN, feed forward network. So this is the data that we have ingested already. You will see driver related attributes, vehicle related attributes, all of them here. Again, we can see the summary, we can see the preview, and the yearly premium. The last column that we see on the screen is what we are going to predict as a supervised learning model. So after having a look at data, we can again do the same thing with auto EDA, which I just showed in the previous demo. So I'm not going to repeat here again. Then we will do the data preparation. So here again, we need to do duplication. Since we have some duplicates in the data, we need to do feature encoding and data scaling. Scaling is particularly very important in this case because we have the indication that we want to use the uh, feed forward network, neural network. In the previous demo, you have seen how are we trying with setting up the experiment. Here we already have a model that we have selected, and for that we need a particular data pre-processing step to be done. After that, we can also write our custom code here. So this is one functionality which gives you agility and flexibility to uh, include any library, any Python library. Now let's look at our pre-built model that we have already built. So here you will see multiple different layers of neural network along with the total parameters. So here we are just trying to fit 3777 parameter to be precise. After having a look at the model, we have the test data pipeline also ready because we have split the data into train and test. And now we are going to use the predict node to be able to predict and then finally evaluate the model. And as I said, this model we have already tried out in the experimentation phase, and this is our champion model. You can see the R square value is pretty neat, right? So 0.93, which is a measure of good fit, I would say. Now, after looking at the metric and being satisfied with this particular model, let's move on to the next dimension, which is the image data. In the same workflow where we have just read the tabular data and created a model, we can also ingest the image data using our image data, read image data node. And this is, we can also look at the preview of the data. So let's look at some of the car images. So these are like high risk damaged car images. And then after looking at it, finally we will go back and we will do some feature pre-processing again for image data. And here also we are doing the encoding, and finally we are going to use the image classification node. So out of the box we have two computer vision functions available. One is image classification, another one is object detection. So when you are trying to detect a custom object, multiple object in one image, then you have to use object detection. Here we are going to classify the image as high risk or low risk. So we have selected image classification. The next is to select the which particular model we want to use here. So here we are going to use MobileNet v3 small, since we have not selected GPU right at the start. And then finally we can set up general parameters like epochs, batch size, etc. Loss function, very important. Or else if I want, I can also go into advanced parameter and I can try configuring each of the layers of my CNN model separately, how I want to handle the transfer learning task, right? Once I train the model, this is how the model summary will look like. So in model summary, uh, yeah, so now model is ready and here is the model summary. So here you will see 900,000 parameters has been trained, and this is the difference between classical machine learning where you have few thousands of parameter versus computer vision where you have few hundred thousands of parameters. And in generative AI you will see that there are billions and trillions of parameters, right? And now I will move back. Since my model is ready, I can use the unseen image to predict based on the data that we have, blind test data that we have kept without showing it to the model. And then finally we can combine the result. But before we combine the result, we will go to the third dimension, which is time series analysis. So here we have created a simple auto ARIMA model to predict the overhead charges for a particular company. Things like expense ratio, things like inflation needs to be adjusted in their premium, right? So for that we have some historical data of last 10 or 15 years. Using that historical data, we are trying to train a time series model here. So this is how your data looks like. This is just a univariate time series data. And then we have trained our auto ARIMA model. You can see the model summary again on the screen. So it will, since it is auto ARIMA, it is going to select all your PDQ value automatically. We don't have to think about a stationary and all those aspects of time series data. Now, after that, I will again predict on unseen data for next few years using time series model. And finally, it's time to create a heterogeneous heterogeneous ensemble model to finally get the output here. And this is how our final premium will look like. And again, we can do the entire MLOps, which we have seen in the other demo, in this case as well. Now let's quickly jump onto our next use case and explore this innovative use case from the insurance industry, where we have privately hosted the multi-language model, multi-model large language model. The problem was to detect anomalies such as duplicate in voice and also enable user to interact with the voice data in natural language. Invoices are often unstructured in nature, and hence classical OCR like Tesseract will not work here, right? It would not suffice. Instead, we decided to use LLM with vision capability, since we could not have. Now another complexity is that we cannot send out the data outside because this is IP data. So we cannot use a multi-model vision model which is hosted outside our premise. And that's where we have used Llama 3.2, which vision capability, which was just released for solving this use case. So that is the reason we have extensively used Jupyter Notebook here, because since we had to write all the code at our own, there was no pre-built library since Llama 3.2 was just released. So here we will read some parameters using read data node, and then we will just transfer those parameters to Jupyter Notebook, and the entire code is written in Jupyter Notebook, which also shows that you can not only use the low code part of this platform. If you have to solve a complicated task, you can write your own code, and this system will give you the complete flexibility to integrate any new advancement in generative AI or in machine learning field. So there is no boundary as such of what problems you can solve using tcgmcube AI 2.0. Now let's quickly look at how my data set is looking like. So I will show you one or two invoice here. So this is how invoice looks, right? So this is a scanned document, but at the same time, there are some structure inside it, which needs to be preserved if you want to effectively query this data and effectively extract the information from this data. And that was the main reason we wanted to utilize the vision model. So we have used, as you can see here, we have used Meta Llama 3.2 11 billion parameter vision instruct, along with E5 Mixtral for creating the embeddings. And we have inbuilt in Elasticsearch inside tcgmcube as our vector embedding storage. So this model not only extract the information, but also structure the data in a way that you can ask questions to the data. So this is how the output structure looks like that you see on the screen extracted from the data. And now I will quickly show how we can ask questions and which type of questions we can ask from the data. So for example, for the invoice this and registration number this, what is the total of part for the total column? And again, LLM is able to calculate and give us the answer for this part as well. This use case was particularly very exciting because Llama 3.2 was released on 25th of September, and within a week's time, we were able to do this pilot and show the value to our end client. And this is how we truly bring the velocity in delivering the value using tcgmcube. Thank you, and over to you, Andy.
All right, Ashutosh. A very, very impressive mix and match of Gen AI as in a traditional sense, like time series models. And I think this really shows how we move into the future. So thanks a lot, Ashutosh. Looking at the time, let's move to one question that we would like to answer, because otherwise we are running out of time. Aditi, can you dispatch the question, please?
Yes, absolutely, Andy. Thanks for the great and interactive session with the with the deep dive demos. So we have time for one question, but we have a lot of questions from the audience, and we will get back to you over an email. So in order, the first question that we are going to take is, how can tcgmcube help me accelerate my clinical trials?
Sounds like a question for Panchali.
Sure, I'll take that, Andy. So tcgmcube can provide smart data management, facilitating the rapid analysis of vast quantities of structured and unstructured data, because there's so many data types associated with the trial, and suggest effective interventions to improve the outcome of the trials. Now, what comes in really useful is it's powered by Gen AI-enabled intelligence and semantic search capabilities, which makes it really easy to extract contextual knowledge from this repository of data. And there could be different use cases. One particular one which which is really helpful is clinical trials performance management with agentic AI. Now, with that, you can have a holistic performance of the trials with a set of comprehensive, on time, on target, on budget metrics with alerts, proactive alerts, and actions taken by the AI model. We can also look at things like regulatory intelligence engine to predict potential health authority query patterns, and then draft the appropriate responses to some of these. So it just doesn't have to be HAQ. The whole submission on the content generation engine can also be used to kind of create an 80% right first draft from the underlying protocol, statistical analysis plan, tables, listings, and so on. It can also have huge applicability because the semantic layer is really powerful. And with that contextual knowledge and large language models, we can have a patient to trial matching engine, which can match patients' data with clinical trials inclusion, exclusion. And this can really help, pharma companies accelerate recruitment and patient access to experimental therapy.
All right, thank you so much, Panchali. As we have seen here, if you ask Panchali about one of her favorite topics, you get a webinar as of itself as an answer. So thank you so much for your very extended answer. And to the audience, thank you very, very much for your attention. I really hope the launch webinar has inspired you, and we look forward to engaging and discussing the impact that tcgmcube5.1 can have on your business with you soon. So until then, stay free of hallucinations as we are opening the door to agentic AI. See you soon.